Okay, this is Math 2, Chapter 10, 84 to 87. The first one says, for each diagram below, write an equation to represent the relationship between x and y. It's actually not asking you to solve it. It's just asking you to set up what do you know about it. So this is actually a pretty good review problem in general. Let's see, on the first one, part A, x and y are in alternating angles with each other. Since these are parallel, that makes the alternate interior angles, which are these two right here, equal to each other. So technically, in this case, whatever you may find, x is actually going to be equal to y in this case. So whatever you have for x, it's always going to equal to the y. All right, this one. Let's see. X is the inscribed angle. This is your arc out here. So whatever this x might be, you're going to double it and get this out here. So technically out here would be 2x. But since y is your central angle is going to be the same as your arc. I'm assuming y is a central angle because it didn't really say anything, so I'm just going to take a leap of faith here. Since y is your central angle, this is your arc, and your arc is technically 2x, technically, so then y has to be equal to 2x, because it's the same out there. Y equals to 2x. And then the next one, these were your proportional or similar triangles. So technically, if you want to do the proportions correctly, 3 times y, so 3 times y is going to be equal to 5 times x. That was the, that was the aha thing that you were supposed to figure out in the other one. So 3 times, this length times this length is going to equal this length times that length on each other. And then the next one, this is a quadrilateral inside a circle. So since they both end up making 360, this angle here, whatever this might be, right, it's 2y. 2y, because it's actually, here, it actually might be easier to do it this way. Right, so this angle here belongs to this arc, right? So this one is 2y. This green angle here belongs technically to this arc, so this is 2x out here. So 2x and 2y essentially just make up the entire circle, so 2x plus 2y is equal to 360. Well, we can actually clean this up a little bit more. I could take out the 2, we have x plus y equals 360, divide by 2 on both sides, then x plus y actually has to be equal to 180. So that's a little bit of a better situation, but this one right here, to me, kind of works just the same. It didn't really say to describe it. A simplified version, but both of them are true. Okay, that was 84. 85, you should kind of know what to do with. I'm hoping by now. They're all pretty straightforward, except maybe A and B. The easiest thing to do would actually be to say, okay, 4x minus 2 squared is equal to 100. If you actually square both sides to begin with, you get 4x minus 2 equals 50, and then you can actually solve it. Oh, sorry, plus or minus. Oh, 50. Holy moly, I can't believe I just did that. Equals plus or minus 10. Wow, that was lame. And then you get 2 answers there to solve it. And the same thing here, technically, this is actually already equals. You don't need to solve it. This one actually needs an inequality. So you actually do have to put it on a number 9, put the 0, find the 2 answers, shade which part is true. Same thing for C. Part D is actually, if I'm not mistaken, I think this is going to give you, let me see, 2x squared minus 6x plus 5 equals 0. Yeah, this is going to give you a negative underneath the radical, so you actually need to solve this using i's, or part D anyways. 86. You should know what to do with these. I'm just going to remind you to set up. Since they're both equal to y, you can actually use the equal values method on this one. So you have x minus 6 equals x squared minus x minus 2 as your first setup, right? And then solve it from there. Make it equal to 0. Do whatever you want if you want to use quadratic or factoring. And then you need 2 answers. You need to plug for x and then plug them back in and find the intersection points where the line hits the parabola. And then the same thing for part B, right? It's pretty much put them equal to each other, solve for values of x. So you should get ideally, right? Unless they never intersect, in which case you should see, if they don't intersect each other, you should get I's like you did for D or you should get a negative radical sign. Or negative underneath the radical sign, I should say. So if they don't intersect, you should get a negative, but I would just double check your work. Okay? Or a negative, not negative, you should get negative underneath the radical sign. Negative value underneath the radical sign. Right, and then 87 is the last one. Where are we at? For the function, sketch the graph. Okay, that shouldn't be too easy. When is the function, or where is it increasing, and what's the maximum value? Okay, this should be pretty easy to do. At -4 and +1, there's the vertex. So -4, 1. And it's negative in front, so that means it's going to go down. And then, so that's a sketch. It didn't say anything about x-intercept, so I'm going to assume they're somewhere over there. Where is the function increasing? So it's really actually, it's going up between any number that's less than -4. So technically, any number on the x-axis that is less than or equal to -4, that would actually be increasing. What is the maximum value? Well, your vertex is pretty much your max. So your vertex of -1, 4. I'm sorry, -4, 1 is your vertex, is your maximum value. Okay, and that was the next part. See you in the next one.